Welcome to the module on Python strings. In this module, you will learn about the implementation of strings, which is a sequence of characters that are symbols. After going through this module, you will be able to create a string slice in Python, explain immutability in strings, list built-in methods in strings, explain the role of format operator, and explain the concept of string modules. The most common form of data that a program handles is text. In computers, text is treated in the form of strings, which act as prominent building blocks of programming. A string is a collection of ordered values. It is a sequence of characters that are symbols. In Python, a string is a collection of Unicode characters. Computers cannot understand characters because they only understand binary numbers, that is zeros and ones. Characters viewed on screen are internally stored and manipulated in binary language. This conversion of character to a number is called encoding, and the reverse process is decoding. The two most popular encoding used are ASCII and Unicode. A string is created by enclosing characters in single quote or double quotes. Python treats both single and double quotes in the same manner. Sometimes, triple quotes are also used, which generally represent multi-line strings and docstrings. So, everything that is delimited within quotation marks is considered a string by Python. In the example shown here, "Have a nice day" is considered as a string. Let's now print 3 lines of text using strings. The program here shows that different quotation marks can be used to print lines of text. When you run the program, the output will be as shown here. Individual characters of strings can be accessed using indexing, and a range of characters can be accessed using slicing methods. A string in Python is indexed using the zero-based format, that is, the first item in the sequence is indexed as number 0, the second item as number 1, and so on. Also, if a user counts characters from the end of a string, negative indexing is considered, and the count starts from -1. Consider the example here. A positive value of 4 prints the letter N, and a negative value of -3 prints the letter H from the string. Let's now understand how to access a range of strings in Python using slicing. We can call out a range of characters from a string by creating a slice, which is a sequence of characters within an original string. We already know that to reference a string, we use an index number in square brackets. We can call multiple character values by creating a range of index numbers separated by a colon as displayed on the screen. Python supports string slicing in a much enhanced way, with a known position and size of the index. A user can not only specify the start of the slice of a string, but also where it ends. The first index number is where the slice starts, that is inclusive, and the second index number is where the slice ends, that is exclusive. While slicing, you must take care of the following. A slice begins with a character at the first position, and includes all characters up to, but not including, the last character of the string. For example, str13 equals tr. If the first position is left out, then it is assumed to be 0. So, str3 equals str. If the last position is left out, then it is assumed to be the length of the string from that character. It includes all the characters after that index. Let us look at the program for a better understanding of slicing in Python. The program illustrates the slicing of a string through positive as well as negative indexing. On running the program, the output will be as shown here. Python does not handle changes for all objects in the same way. Some objects are mutable, which means that they can be altered, while some objects are immutable. A string in Python is also immutable and cannot be changed, but can return new objects when it is updated, albeit unsuccessfully. Look at the example. The code will show an error when we try to change the first character of world from W to Z. Some advantages of strings being immutable are: it saves a lot of time in fixing and on changing the storage requirement times. This directly results in high performance. String objects can be reused, as they are safely stored without getting changed. Strings in Python are considered as elemental as numbers. None of the activities can change the value of a string in Python the way the numbers cannot be changed. In the program displayed on the screen, note that we have taken a string and a substring value and applied various string operations on it. The max method returns the oldest character occurring in English alphabets. Also, the center method returns the string with the given attribute defined in the center position of the screen. And lastly, using the count method, the string counts the number of occurrences of a substring in the string. Now, take a look at the output of the program displayed on the screen. Python provides two format operators for formatting sequences: percentage operator and curly braces. Format operator is used to format integers and strings. The percentage symbol is used as a format operator. When the percentage operator is applied to the integers, it is known as modulus operator. And when the first operand is a string, the percentage operator is known as the format operator. The first operand is the format string, which contains one or more format sequences that specify how the second operand is formatted and return a string. The percentage %d represents the modulus operator, where d is the decimal value which formats the integer. As you can see from the figure shown on the screen, a string is assigned to the variable name. The next line of code is applied on a string, where %s formats the string using % operator before the variable name. Now, take a look at table displayed on the screen. If you want to format more than one sequence in a string, then you must use a tuple sequence. To format the tuple into a string, apply the percentage operator before a tuple. A module is defined as the file that contains the definitions and statements of the Python language. Usually, the file name is the module name saved with the .py extension. A module contains executable statements as well as the function definition. The execution of the module can be done using an import statement only the first time. Each module has its own private symbol table, which is used as a global table by the function definitions in the module. String modules in Python are collections of various functions, constants, and classes that are useful to process standard Python strings and Unicode objects. There are various string modules. They are as follows: constants, functions, templates. In string modules, Constants can be used to specify different categories of characters, such as ASCII letters and digits. Some of the constants are locale dependent, which means that when the value of a constant changes, it gets reflected in the user's language settings. For example, the lowercase constant is locale dependent. Some of the constants do not change even with local changes, such as hexadecimal. String modules comprise two functions as displayed on the screen: string.capwords and string.makeTransFrom. 2. The string module with the template class implements some of the string template modules displayed on the screen. The summary of the module on strings is available on the screen. I will pause for a few seconds to allow you to read it. Internalize this information and apply it to gain mastery over the concepts. In the next chapter, we will discuss arrays. Thanks for watching the video.